Hi, everybody. My name's Sachdeva, and I work at a company called Vonage. I was part of the TalkBox team that was acquired last year, and we're part of the API platform. And today we're going to be talking about unique use cases that we see that are kind of evolving the requirements of how we're using WebRTC. And just to take a step back, we're an API platform, right? So we see a lot of different use cases, something that you may not think, just based on regular streaming, somebody just trying to use, ways to transmit data. So we'll look at it from that level, and we'll kind of show you little demos in here on. So I want to take a step back and talk about the very basics. So if you've ever used WebRTC or are looking into WebRTC, you'll always realize there's like a way to transport media, and there's a way to transport data through data channels. And I've drawn this amazing diagram to kind of show you what that looks like. So you have audio, video, and data channels. And the reason I bring it up here is because one of the key problems we face today is that there's no way to synchronize this data. And it's really hard to do a lot of these things in the browser as well. So I'm going to show you something called a demo. It's really awesome. And it's live, so let's hope the demo gods are with us today. There's no best way to live demo. So I'm going to reload these things. I have a very basic JavaScript application, and I'm just going to connect both of them to my signaling server here. And I'm going to send video, and this is just our way of sending video. It's a publisher-subscriber model, and it's the OpenTalk API. But I don't know if you can see it in the back, but you can see some sort of captioning system. Sometimes it works, sometimes it doesn't. That's the benefit of a live demo. That was the whole joke. Thank you very much. So the whole point is that we're kind of seeing me talk. You can see my face and the audio coming in, but the captioning is a little slow, a little not synchronized with the way I'm talking, right? So it's a huge problem that we're facing. We're sending it in, and that could be the way maybe we're doing transcription, because it obviously another cycle that you have to go through. But even if you did that, the audio will flow in before, and you won't be able to synchronize it because you don't know when one comes or the other. And they're two completely different channels. One's a reliable channel, let's say for the data channels, and one is an unreliable channel, let's say for our media being transferred over UDP. So hopefully you get the whole synchronization problem here, and to set the bar, and I'll move back from my demo. Just disconnect real quick in case we need to come back. And I want to talk about the architecture. It's very basic. As you can see, if you've ever seen a WebRTC slide, you'll see a signaling server, two peers, transporting media, and a data channel for our transcription. And I put GCP there because the way that I'm doing transcription in this case is just using the speech recognition API available in Chrome. And that requires the network, goes to GCP, comes back, and sends that information over the data channel. And obviously, there could be other approaches. Maybe we have a media server in the middle, and you hit the media, and then it transcribes there and sends it via data channel. That might help us, but there's still no guaranteed way of kind of delivering it in a synchronization way. And we'll kind of talk about different use cases where this may be more and more requirement. And some of the things that we see are teleoperations. So we see a lot of robots, a lot of people doing surgeries, believe it or not, over video. It's kind of crazy. I did pre-med it one day, but I don't feel comfortable doing that. So robots. So we have one of the customers, essentially, who is streaming back video to a control center. And this is a very simple use case, right? You're sending in video. But the robot is collecting very essential information. It's collecting, the location, maybe the collision detection, or the weather, whatever is relevant for the robot. I'm not an expert in robotic technology, but I think it can easily identify these things. And they have a way of signaling back to the robot to say, hey, make a left, make a right, hit the tree, brake, die, whatever, right? The whole point of this is that maybe it's even more crucial in this case to kind of bring that data in, the sensor data or whatever's relevant, at the same time you're getting the video frame. I know some of you are thinking this is possible today, so we'll kind of get to that a little bit, but not everything is possible in that sense. So this is cool, but the stakes are even higher when you're doing this telesurgery thing, right? Like if there's a remote surgeon who's the renowned brain surgeon, or somebody who's doing surgery all the time, it's helping the surgeon who's locally there. And this is an iPad essentially superimposing, it's using AR, superimpose these things. But the remote surgeon needs information like maybe the vitals, the blood pressure, O2 sats, the body temperature, some other things that we may not know because we're not experts in the health industry. I'm not. But I know it's important to get this information synchronized with the video because you're receiving. Because when you're doing a surgery, things can happen very fast. Somebody's heart rate could drop immediately, and you might need to do that. And every second, every 300 milliseconds counts. And you should have that synchronized with the video stream that you're getting. And I keep pushing on this, and we see this with AR, other use cases. And the way people have solved this is, encoding data with a specific frame. And a couple of years ago, we released an API called Frame Metadata. And that Frame Metadata API essentially leverages the RTP header extension, encodes information, and sends that over. So the way it works is you capture the frame from the camera, you add metadata, you encode it, goes over the network, and on the receiving side, you consume that metadata. And it looks very simple on a sample code that I've shown right here. It's on iOS, and I'm sorry if you can't see this in the back, but if I hover my mouse over, just creating a timestamp for a basic use case, setting the metadata, set metadata, a very good name, I think. And then on the other end, you just receive it. So this is the second slide on the subscriber end. Remember the primitives that I was talking about earlier, pub/sub? And you get this metadata available to you. So now you can actually put information, like if you have a headset on and you're moving around, you want to be able to put the camera, the depth, the angle, everything within that specific frame. So if you come back, you have the same context. On the receiving side, it's the same way. This is really cool, but it's been done before. We're doing it. Our customers are doing it. What if there was a way to do more? I want to take a quick pause here. If you want to just give me a show of hands if you know what this is. Can somebody raise your hand? And I'm not just talking about a panda. Okay, it's an Animoji, right? So for those of you Apple lovers out there, Apple released this in one of their latest releases, so where you can kind of capture your facial expressions, make a video, send it as an attachment and message. It's pretty cool, but what if it was done real time? What if instead of sending the video of you as a user, you actually just sent these facial expressions over the network instead of any video, and on the other side, you just recreate it? That would be pretty epic. Unfortunately, I don't have a demo for you if they're doing that today. I know that would be really cool, but that's where we think this is heading. Because we have state-of-the-art technology available for us to be able to capture this information. If you use Face ID, you have this information. I mean, Apple has it, Google has it with the Android devices, so this is all available at the palm of our hands. And I'm here just trying to advocate for it to be available, and maybe we can do something within WebRTC to make this happen. And the way we envision it working is you capture it, you do some face tracking, you generate a data frame, not a video frame, a data frame. You packetize it, it's synchronized with the audio. On the other end, you deconstruct it and emulate this. And that's really cool with the Animoji real time, but imagine that in a gaming environment. So or virtual reality. I have a headset on. You probably don't want to see me put a headset on, but if I have a headset on and there's some way to recognize my facial expressions, and you can emulate this conversation I'm having with somebody else across the world, and it kind of feels real. And this, I think, is really important in gaming. And this slide doesn't say a lot, but it says WebRTC in gaming. And the reason I mention is because there's a lot of people in gaming making an investment in WebRTC, and we see our developers doing that for us. Epic Games, they're not our customer, but I'm saying they acquired House Party earlier this year, if you know what that is, right? So they obviously want to replace their VoIP technology in Fortnite, but if you replace that, you already know how much usage Fortnite's going to be bringing. It's a lot of people using WebRTC. Unity, a platform, developers, you build stuff. People want to add voice communication, video communication, messages. But nobody in a real game kind of wants to be able to send your face in a game. You want to probably have an avatar, because that's what's a natural experience in a video game. And within the avatar, you emulate everything, and you do like the Animoji experience within a game. We have a Unity SDK that kind of allows you to do some of these things. You can capture the video within a camera inside of the Unity game. And the way we built our SDK is we have the WebRTC native APIs, some of our patches, OpenTalk primitives on top, a Unity DLL, which has a similar same API as our Windows SDK, and then your Unity code. And we provide you with Unity renderers and capturers, but you can provide your own if you'd like. So you want to render on a texture, however you want, it works. But remember, the story is to be able to synchronize this information, because you cannot, at this point, send everything. And there's been some research. People have been looking at it. I think there was an article I saw in IETF proposing to be able to send augmented data and making a standard out of it, because that's the whole point. We can try something, the slide that I showed you in the past, but somebody else tries this. But there are standards of communication right now with the RTC peer connection and things like that, and I think we'd like to see that someday being standardized within the WebRTC community. Thank you.